Okay, shall we start? Good evening, good evening. No, it's like the fifth day, you should know. Okay, wait. All good. Okay, good evening. Okay. So, first of all, sorry for the delay. That's why I came around and informed what happened because, okay, normally when students come to say results, like come to inform their results, I normally give some time slots. So, like I have given a time slot from 2 to 3, and then I was been talking to them who came at that time slot. Because normally I don't like to go out from the class. Like let's say I'm here and a student comes, hi, say I got the A. So I don't like to go out, walk out from the class and just have a chat with him. That is one reason. And when I'm talking with a student, I need some ample free time so I can freely talk with him. So when I just come to the class at the like when when I am in a class, when I go out and have a chat with him, I'm with the mindset that I need to quickly go back to the class. So that doesn't give me the the freedom to talk with him like in a normal way. So that's why I have normally given time slots for students to talk with me. But like even though I gave 2 to 3 time slot, there were like quite a lot students who came today. So that's why, and from my end, after like they have attended to my classes for like 2.5 years and attending for 2.5 years, and mostly the students who are coming to say results have probably it's a A pass or a B plus because very rarely a student who takes a C or S pass comes and talk with us. So most probably when a student comes, either it is a A plus or B plus. So like I don't like measure students whether he or she has got a A or B or C or S or whether she or he has failed the exam. I don't judge or measure students, but if he is a student, I spend my time to talk with him. So and like from their end, like I can't ask them to come on another day. Now I have to go to the class. I think you can understand the situation because it's not nice after they have attended. Like imagine you are attending to my class for these 2 years and 3 months, and you are getting a B pass or A pass. And when you come to the class and I'm asking you, I have to go to the class. Can you come on Friday? Can you come on Saturday? That is something not nice, even though I'm a teacher. So I think you can understand the situation. So that is why we got late. And even the students who have joined online, we uploaded the link by 3:15, but now only we are starting the class. Sorry about that. And the students who came in the last month know that we are punctual. We normally start the class by 3:35, maximum 3:10. Okay, not that not next week. Next week is holiday. Week after, don't come to the class by 3:30, 3:45, assuming that I get late every day. Okay, don't do that because if that happens, it becomes a practice. And I'll give a comprehensive analysis about the results of our class. Not like probably I can give it next week, but since next week is a holiday means the vacation period is the 13th. No. So New Year, no, so week after when we are meeting, I'll give you a comprehensive summary about the results of our class. So far, like in Colombo district, we had district 6, 10, 14, and 20 inside the top 20. But I don't consider that district 6 student as a result of my class because he didn't attend our theory class. He only came for the paper classes. I normally do that. If a student haven't attended the theory classes, only have attended the paper classes, I don't consider it a result of my class because I haven't teach or taught that student. He has learned the syllabus from somewhere else and he's just coming to our paper class to test and write the papers, to test his knowledge. So then I don't have ethical right to talk about that one. Even that happened in 2023. In 2023, the district first and second both students, one from Anand, the other one from Royal, came to our paper class. But still, I haven't mentioned it in any of our handbills. And normally, I'm a person who doesn't market the ranks because what I believe is a student who get a rank is like the 100% credit should be given to the student. A proper teacher is the one who is having a good AB percentage. One is who is having a good pass rate in the class. Is a proper teacher according to my benchmark. So I'm someone that I'll be not that I want market ranks. If I get island first, district first properly, who have attended my theory classes, I'll just mention that. So I'm not normally in this thing that where I market students. And even if one of the students become district first in the future from our class, I'll just mention that the district first is from our class, and I'm not going to display his pictures or names because I say that I thoroughly believe that students are not marketing materials. So we can just market, we can just mention that the district first in our is in our class, and I prefer to put my photo in a handbill rather than put in a photo of a student who has become the district first. Okay, so that is the Colombo district, and there were few students who were like outstation ranks. Yesterday only I got to know that two students from Ratnapura district second and district 19, they have attended my online classes. I didn't even know about that. Yesterday when they came to talk to me, only I knew that those two were there, district 2 and 19. Then I'll give you a comprehensive analysis about the results on the 20th of April. How many students went to the exam, faced the exam, how many A passes, how many B passes, so what is the percentage of A passes in the country and in our class, and what is the pass rate. So I have mentioned that in the very first day of the class. I normally believe if the class is having a good quality, I need to, from that is my own benchmark, that is on my one, not a not a standard one or a public one. I believe if I have done a good job, the AB percentage of the class should be more than 50%, should be more than 50%, and the pass rate should be more than 95%. If anyone is doubting, sir, AB percentage is 50% means like you are telling like if there are 100 students in the class, only 50 students has taken A or B passes. If you think that is less, for your information, the AB pass rate of the country for combined maths is around 16%. It's around 16%. It's like basically out of 100 students who are writing the combined maths paper, 8 students take A passes and 8 students take B passes. So the country's rate is 16%, which I try to maintain about 50%. The country's combined maths pass rate is normally around 60-65%, which I try to maintain in 95%. Okay, so week after, let's talk about the complete results analysis. So today we'll start the lesson. So even like I see not couple, many newcomers today, because probably it is a new month. So even you are a newcomer, you can easily understand because we are starting a new lesson today. Okay, we are commencing the syllabus. So then you can easily understand from this one. And there's one small part remaining from what we have done in March. We have done a part called, what did we do in March? What did we do in March? Now all our newcomers can't remember. We have done this basic mathematical concepts. So basic mathematical concepts is that the bridge that is connecting O-level maths and A-level maths. Okay, I'm not going to draw the graph today even because I have drawn the graph for 4 days, 4 weeks. So let's say you have scored 70 plus, 80 plus in O-level maths, and then you come to do A-level maths, and even though you have scored more than 90, when you come to do A-level maths, there is a small gap between where you have stopped during your O-levels and where you are starting from A-level maths. Your O-level maths knowledge is more than enough to do bio, tech, commerce, and even arts. Arts probably enough. But to do maths, there is a small gap. So we have been covering that gap between O-level maths and A-level maths for the past 4 weeks. And there's one more small part, simplifications related to fractions, which we'll be doing today at the last half an hour of the class. But I guarantee that even you are a newcomer, new student, that is totally okay. You will be able to understood the today's entire class. Okay, but I only need two things. 100% focus when I'm teaching, when I'm explaining, focus on the board, focus on what I'm explaining. And when I ask you to do a problem alone, stay silent, do the problem, attempt the problem, try the problem alone. If you do that two things properly, I'll guarantee from my end that you will be able to understand this completely. Are we clear? Okay, so online students, if you have any doubts during the class, you can clarify them, send a message in the chat. I'll be checking the chat on and off. And if you all have any doubt when I walk around the class, you can talk to me and ask me. So I didn't understood this one. How did this come? All good. Okay. Okay. Killing it. Lesson. Good. Okay. Right. The first topic of the syllabus, number systems. Right. The first topic of the syllabus, number systems. Newcomers, you don't have to keep any blank pages for complete the previous work. Just start from this one, number systems. Number systems. Number systems. So number systems. Okay. So when we talk about the numbers in the world, not in the world, you don't find numbers in the world in maths. You don't find, like when you go to India, you have number one. In Sri Lanka, you have number two. In America, you have number three. No, you don't find numbers in the world. You find numbers in maths. First thing, tell me what is the number system that we are using? History of numbers. What is the number system that we are using? One, two, three, four. What are these numbers? What numbers? These are Hindu or Hindu, because it's based on India. What is the other nation? Arabic numbers. The numbers that we are using is 1, 2, 3, 4. This base 1. I heard something like decimal, or you can even say that base 10 numbers. So these are Hindu Arabic numbers. So what was the number system, the most prominent number system before Hindu Arabic number systems? Hindu Arabic number systems, it was the Roman numbers. Still we use Roman numbers. No, sometimes you use Roman number 1, Roman number 2, Roman number 3. Anyone who knows the reason why did this Roman number system declined with time? Because the Roman Empire destroyed. No. What is the reason the Roman number system declined with time? The main reason is when we write big values, you have to use so many symbols in this Roman number system. For example, like if we like something like let's say 123,421, to write this in a Roman number system, you will be using like I don't know exactly how many digits or how many symbols you have to use, but probably you have to use more than we can let's say more than 7, 8 like symbols will be used. So that is one main reason why the Roman number system declined. Anyone who knows the reason, why did the Roman numbers, when you're writing numbers or values using Roman numbers, why did it become this much lengthy that you have to use 8, 9, 10 characters? What should be the reason? There was one major issue in the entire Roman number system. Anyone who can guess the reason? You can remember these Roman numbers. I is 1, V is 5, then X is 10. Then we have this L, D, C, like I can remember, L is 50. L is 50. C is probably centuries, 100. Or like we had these, and we had D, something like 500 or 1000, and M. Those were the letters. We had I, not we had, they had the I, V, X. Then we have L, M, C, and D. If I'm not mistaken, those were the 7 characters in the Roman number system. The main reason for the fall of Roman number system is they didn't have a zero. They didn't have a zero. That was the main reason. The main reason why did the Roman number system is not popular, not used anymore in nowadays, the reason is they didn't have a zero. Because they didn't have a zero, they had to write these lengthy expressions to express a big number. So after the Roman numbers, then came the Indo-Arabic numbers, which is still used and hopefully which will be used till the existence of the world or until Trump dies. Okay, so probably this will be the number system that continues until again we come back to a Jurassic era. Okay, that happens, no? So like we will be destroying our own world, and then again we will be going to the Stone Age. So that is how the world goes. That is how it goes. So this will be used. Okay, so when we talk about these numbers, Indo-Arabic numbers, the entire number system can be classified into two main categories. The entire number system can be classified into two main categories. The first or the main category is our topic. It's real numbers. The entire number system can be categorized into two. This is the main one, real numbers. And the other one, what should be the other one? Fake numbers. If this is real, it's fake. No, we call it imaginary numbers. The other number, category is imaginary numbers. So the entire number system can be categorized into two main types. The main one is real numbers, and the other one is the imaginary numbers. Other one is the imaginary numbers. Okay. Okay, first let's write this one. Write it this way. Number systems or numbers. Online students, if you have any doubts, you can ask in the chat. Okay. Number systems or numbers. Number systems or numbers can be mainly classified into two categories. Mainly classified into two categories. Two categories. Okay, then write in this way, you have number systems, so just write numbers. No need of writing numbers here. Put numbers and then split it into two parts, real numbers and imaginary numbers. So let's discuss them separately. What are real numbers and what are imaginary numbers? Real numbers and imaginary numbers. Okay, then using a black pen, write number one, real numbers. Using a black pen, write real numbers. Using a black pen, write real numbers. Okay, so what are real numbers? The definition of a real number is, so this is the sign of a real number. So this is how we denote a real number. It's denoted by a R, but it is a modified R. Near this one, we put another line. It's not IR, not IR. So this is the notation of a real number. It's the R, but near this R, you have this line. So then using a black pen, write real numbers, and then within brackets, even write this symbol. Can see it? Yeah, can see real numbers. Okay. Okay, so what are real numbers? Numbers that can be denoted on a number line are simply termed as real numbers. So if you can denote a particular number on a number line, we say that number is a real number. So that is the definition of a real number. So here we have a number line. Any number that can be denoted on this number line is a real number. So we have 0, we have 1, we have 3 over 2, we have root 7. From here we have, let's say -1, we have -3.2. So minus numbers, decimal numbers, fractions, integers, root values, all these are real numbers. All these are real numbers. That is the main category. That is the main category. So any of these numbers can be denoted on the number line. So it comes under real numbers. What are the examples of real numbers? I have already shown the example. We have integers, we have negative numbers, decimals, fractions, root values. So all these are real numbers. It's like when you name a number, it's a real number. Like name a number, oh, that is a real number. It's like in that way. So then you will be asking, so then what are imaginary numbers? I'll tell them, because why did I say that name a number? It is a real number because you won't be naming an imaginary number. Okay, so every fractions, decimals, integers, root values, all these are real numbers. Okay, under these real numbers, like you have written this in a black pen, and then using a normal pen, write in this way. Numbers, numbers that can be denoted numbers that can be denoted on a number line, on a number line are real numbers, are real numbers. Okay, first write the examples and then denote them on a number line. First write the examples and then denote them on a number line. So we have all numbers, decimals, fractions, minus, plus, all. You don't have to denote the exact number here, just write few examples to have the understanding that we have integers, minus numbers, positive numbers, zero, decimals, fractions, and root values. To have that understanding, only write the examples. Okay, like then there is another feature of a real number. Now look at this. I'm going to square these real numbers. So when you square 1, 1 squared is 1. When you square minus 1 squared is plus 1, because we know minus number squared, you get a plus. Then let's say root 7 is squared. Last week we learned this. What is this? Root 7 square. The square root and the square cancel off. You get 7. So it's clear when you square a real number, it is always a positive value. When you square a real number, it is always a positive value. Because of this, we say when you square a real number, we are getting a positive value. But there is one exemption. What happens when you square 0? What happens when you square 0? 0 squared is 0 into 0. You are not even sure about your O-level maths knowledge. 0 into 0. Tell me, don't give me goosebumps. 0 into 0 is 0. It's 0. Okay, so when you square 0, that is 0. So we say when you square a real number, every time we get a positive value, except one exemption is there, it's 0, because when you square 0, it is not a positive one, it's 0. So within brackets, I'll be mentioning O0. If not, that is a feature of a real number. When you square any real number, you will be getting a positive value. Clear? Okay, right in this way, write in this way. When a real number is squared, when a real number is squared, when a real number is squared, the value is always positive. The value is always positive within brackets O0. Within brackets O0. I can just show these examples. Let's even square a decimal one. 2.1 squared is equal to 4.41. So all these are positive values. So I have even given the exemption that when you square 0, it's 0. So that's why within brackets, we go with always positive. O0 can be 0. Okay, so tell me, what is this that we have? Why do we use, like, here it's an example. So for example, you write EG, sometimes you write EX. If it is X, like EX, then you know, okay, that stands for example. But you use this EG, no? Anyone know why we use a EG for example? It's not example, no? So then why do we use a G? How did you get the G? Seems like grade 6 or 7 you have been using this EG, and you haven't even thought about why does this G stands for. You write EG since grade 6, 7, no? Anyone who knows the answer, why is it EG? Okay, it's a Latin phrase. It's exempli gratia. So that's why we write EG. Like it's a Latin phrase. So those are the things that you need to know. Like let's say that you are walking every day in a particular route for your home, and there is an unusual board, unusual sign. And if one of your friends come to your place and ask in, Masang, what is that sign? Think about yourself if you don't know the answer. You have been passing that sign since childhood, but you don't know what does that sign stands for. Same thing, we have been writing EG, EG, EG. Every time madam says, put an example, EG. So from where did this G come? You thought it's example, like that the first day you told me subtract, okay, no, it's example. So it's a Latin phrase, exempli gratia. Okay, makka. Okay, so now the second one using a black pen, imaginary numbers. Right, the second one, it's imaginary numbers. Imaginary numbers. Imaginary numbers. Okay, so imaginary numbers are the opposite of real numbers, which means imaginary numbers cannot be denoted on a number line. You can't find imaginary numbers on this number line. So what are the examples? The imaginary numbers are these minus 2 root, to root minus 2, root minus 3, root minus 7. These are imaginary numbers. So you can keep in mind when the number inside the square root is minus, we say it is imaginary. When the number inside the square root is minus, we say it is imaginary. Okay, so these cannot be denoted in a number line. So here you have the number line. You can't just denote it, this is root minus 2. No, you can't do that. Okay, so these are imaginary numbers, numbers that cannot be denoted on a number line. And then if you say the opposite of this, when you square a real number, you always get a, tell me, solunga. When you square a real number, you always get a positive one. The opposite. So when you always square an imaginary number, you get a negative value. Square this. A root minus 2 squared. Square root square cancel off, it's minus 2. A root minus 3 squared. This cancel off, it's minus 3. A root minus 7 squared, it's minus 7. So when you square an imaginary number, you get a negative value. You get a negative value. So that's why I told you, you name a number that is a real number. Because when I ask anyone here to name a number, you won't be telling me root minus 2, root minus 3. No, though these are imaginary numbers. Okay, so like these are not common numbers. Very rarely we use these numbers. So in our syllabus, there are 3 lessons that we are talking about this. First occurrence is when we talk about functions, a lesson that we will be doing probably in June or July. And then when we are doing quadratic equations, and when we are doing the last lesson of the syllabus, complex numbers, is only where we talk about these imaginary numbers. Elsewhere, every syllabus we talk with real numbers. We talk with real numbers. Clear? Okay. Then under imaginary numbers, write in this way. Write in this way. Numbers that cannot be denoted on a number line. Numbers that cannot be denoted on a number line are imaginary numbers. Are imaginary numbers. are imaginary numbers. Okay, then first write the examples. Write any value. Don't write the exact values that I have put on the board. You can use them and even write your minus birthday. So everyone should have a unique one. No? If your birthday falls on the second, third, or seventh, then that is okay. If not, put your minus birthday. If your birthday is 21st, root minus 21 should be on your book. Or root 2000 and you were born in 9, no? Yeah, 2009. So you are the one before last batch in the Gen Z, no? Good, good, good. Okay. Then write in this way. When you square an imaginary number, when you square an imaginary number, when you square an imaginary number, the value is always negative. The value is always negative. The value is always negative. Okay, then square and show a few numbers that you get a negative value. Negative value. Few numbers, square them and show that it is negative. Okay. Okay, then like I told you, the entire number system can be categorized into two main categories. One is real number system, which is the main one, and then we have imaginary numbers. And then the real numbers can be categorized furthermore. Like under this, we will be categorizing the real number system, where we have rational numbers, integers, square numbers, triangular numbers, whole numbers, natural numbers. I'm not going to write all, but every other category that you find in numbers comes under the real number system. Okay, comes under the real number system. Okay, then write in this way, the real number system, the real number system, the real number system can be can be categorized, can be categorized, can be categorized. Furthermore, in the following manner, in the following manner, in the following manner. Okay, so main one after imaginary numbers, we have, so you can put number 3 and write rational numbers. Put number 3 and write rational numbers. Put number 3 and write rational numbers. Okay, remember about rational numbers. Remember about rational. I'm not going to ask about did you have this for O levels, but probably you had this. Like even though you had about you studied about rational numbers in your O levels, last week we did this one. Okay, last because I'm like yesterday I decided that I'm not going to ask anything from the class whether you had it in O levels or not. Because like whatever I asked from the class, not even in this class, in the single medium class, when I asked something like, did you have this in O levels? No, sir, can't. No, nothing was in the class. For example, like when today, even when we are doing that, we get this number 999. Okay, like we'll be doing the next part is recurring decimals, and during a simplification, we get this number 999. So I was just mentioning 999, and I just mentioned a name called Angulimal. So Angulimal is a person that in Buddhism is, I don't know whether he's a real character or a fictional character, but that person has killed 999 people, and as a habit, he used to cut off one finger of each person, and then he has made a necklace of fingers of each person, and then he had to, like, according to what we have learned in our religion, it is mentioned that his teacher is the one who has given the task. So he had to complete one more finger to complete this fingers 1,000 finger necklace. So then he met Lord Buddha, and there is a story, because like there is a story in Buddhism that what we have learned. So because of that, when it say 999, Angulimala came to my mind. So when I mentioned 999 Angulimala, Sinhala medium class, like an English medium class, I want to talk about that, because when I say Angulimala, like I bring out proper examples to the proper class. So in the Sinhala medium class, I was saying 999 Angulimala, zero emotions. Okay. No one even, like, half of the class didn't even knew about it. Who's Angulimala? Then I was asking, like, didn't you study about Angulimala from grade 6 to grade 11? You had Buddhism, and you are telling me you don't know Angulimala. Apparently, like, what I got the response from the students, that Angulimala was not in the syllabus. Angulimala. And then we are talking about this recurring decimals. Okay, recurring decimals. So recurring decimals in Sinhala, we call it as Samavartha Dashama. So I told you how does this word come. Samavartha is Sama Avartha. Hands up, who did Sinhala as a language? Sinhala. O-level Sinhala, O-level Sinhala. Okay, so in Sinhala, we have the Sandhi Dibbani, Sandhi. So I was asking then, okay, මේ සම ආවර්ත කියන එක ඔය ස්වර සන්ධි කියන එකක් තියෙනවා. හරිද? The ones who did Tamil, you don't have to think about it. Okay? So ස්වර සන්ධි කියන එකක් තියෙනවා. මම කිව්වා සම ආවර්ත කියන එක මේ මොන සන්ධියෙන්ද සන්ධි උනේ කිව්වහම මොකද සන්ධි එකක් නැද්ද සිලබස් එකේ ඒකක් නැද්ද කියලා. Because I can remember we were learning that and it was a ස්වර සන්ධි. සම ආවර්ත සම ආවර්ත කියන එක. ඒකත් නැහැ. Even they don't even know that one. So yesterday I decided itself I won't be testing your O-level knowledge. So I won't be asking anything. Did you have this in A levels or O levels or not? Because I don't like to have goosebumps during the class. So what I do is, even though it was in the syllabus or not, I'll be even explaining that, talking about that. Okay. But this one is something not from your O level syllabus. We did this one last week. So you even have put the topic rational numbers. But since there are quite of newcomers, I'll be explaining this from the beginning. So that the old students, okay, now tell me, be an example for the newcomers. What are rational numbers? Be an example for the newcomers. What are rational numbers? What are rational numbers? Rational numbers that can be expressed as a ratio integers are known as rational numbers. Good, like, okay, 1 week no, last week no. If we did like yesterday, you could have answered somehow. That's okay, totally okay. Okay? Rational numbers, because I'm not testing your memory. I know you can't even remember what did you eat for lunch day before yesterday. With rice, what were the curries you had? Try to remind them, you can't remember. Try to remind what you ate, unless you ate something special, fried rice. Try to remember what did you eat day before yesterday for lunch. Probably with rice, what are the curries? Try to remember, you can't remember. So I'm not testing your memory. So I'm asking something from 1 week, no. How can you remember something I did 1 week before? You can't even remember what you ate day before yesterday. Okay, that is how human memory works. Human memory starts deleting stuff from 48 hours to 72 hours. So that is how human memory works. Because human memory is even having a RAM and a ROM. So we work with the random access memory, which is the temporary one. Every day what you see in your normal day-to-day environment is your RAM, is your temporary memory. Something that you permanently remembers goes to your permanent memory, to the ROM. You can remember everyone here, like most of the students here can remember your mother's or father's mobile number. Okay, but you can remember your mother's and father's mobile number. You can remember your home address unless you are changing your home address every month. You can remember it. So those are in the permanent memory. Okay, so I'm not going to test your memory. I know you can't remember something that we have done 1 week before, because I don't know whether you are doing the weekly questions or like weekly questions. Because I'll be starting discussing the weekly questions this week onwards. I got a request from the Sinhala medium class. Can you discuss at least the tough questions, the challenging questions in the weekly questions? So from this week onwards, I'll be doing a discussion collectively to the Sinhala and English medium. So I'll be explaining in both languages. Not all the questions, the challenging questions, hard questions, which you think that should be discussed will be I'll be doing from this week onwards. Okay. Okay. So okay, let's come to the lesson. What are rational numbers? Everyone now tell me. You know what are rational numbers? Rational numbers are numbers that can be expressed as a ratio of integers. Okay. So what are examples for rational numbers? Like 2 can be expressed as 2 over 1, which is a rational number. 2 is an integer, 1 is an integer. Half, 1 is an integer, 2 is an integer. So these are rational numbers. So if you write minus 3 again, and when I was doing this, a student from the online class asked me, sir, are decimal numbers rational numbers? You tell me whether 0.1, is this a rational number or not? Yes or no? Hands up if you are telling 0.1 is a rational number. Okay, good. Why are you telling that 0.1 is a rational number? It's 1 over 10. No, yeah, good. So 0.1 is 1 over 10, which is a rational number. 2 can be expressed as 2 over 1, which is a rational number. So what are rational numbers? Numbers that can be expressed as a ratio of two integers. Okay, write in this way. Under rational numbers, write this. Numbers that can be expressed, numbers that can be expressed, numbers that can be expressed as a ratio of as a ratio of integers, as a ratio of integer are known as rational numbers, are known as rational numbers. Okay. Then write down this example, few examples. You have 2 half minus 3 0.1. You can write any example. So rational numbers, there is a sign. So it is denoted in this way. It's a Q, but even that is a modified Q like that one in Q. There is an additional line going inside this Q. So that is the, yeah, that is a view denote a rational number. It's a Q, but a modified Q. Okay. And we have a definition for these rational numbers, which we even discussed last week. So this is how a rational number is defined. A rational number is in the format of, a rational number is in the format of P over Q, P over Q, where P and Q are integers. So here, next topic, number 4 that I'm going to discuss. Number 5 will be integers. So this is how you denote a integer, denote an integer. It's a Z or modified Z. Okay. So we write this in this way. And here there is an additional one that Q is not equal to 0. You can remember when I gave this definition last week, then only I realized that I didn't talk about the biscuit story in the English medium class. So now even you know that story. A denominator can't be 0. The denominator can't be 0 because then we have considered that Q is not equal to 0. So what is the meaning of this definition? The meaning is that P over Q is a ratio K. So this P and Q are integers. So this part means P and Q are integers. So this part says that P and Q are integers. P, Q are integers. So what does this part says? The denominator can't be 0. The denominator can't be 0. So this part says that the denominator can't be 0. Denominator can't be 0. Okay, so this is the definition of a rational number. Okay, let's even write this one, write in this way. A rational number rational number can be defined In the following manner, a rational number can be defined in the following manner. Can be defined in the following manner. Okay, then write this. A rational number is, you can write, copy down the board, copy down what is written on the board. P over Q, P, Q are integers and denominator can say no, can't be 0. So if you write these two, what does this stands for? What does this stands for? Q can't be 0. P can be 0. The denominator can be 0. Sorry, the numerator can be 0, but the denominator can't be 0. Okay, tell me, is 0 a rational number? 0, is it a rational number or no? Hands up if you're telling 0 is a rational number. 1, 2, you are there. Hands up if you're telling that 0 is not a rational number. So there are only two options. Either it is a rational number or not a rational number. Don't tell me no, sir, it's a real number. Yeah, it's a real number. So real numbers are furthermore categorized now. Now tell me, so based on this one, tell me, is 0 a rational number? Hands up if you're telling yes, it is a rational number. Okay. No, it is not a rational number. Okay. So if you say 0, a 0 can be written as 0 over 1. No. 0 can be written as 0 over 1. 1 is an integer. 0 is 0 an integer? Is 0, you didn't have O levels, that's okay. Just try to think and tell me, is 0 an integer? Yes, it is an integer. When you wrote the examples for integers, -3, -2, -1, 0, +1, +2, +3. So then 0 is even a rational number because 0 can be written as 0 over 1. 0 is an integer, 1 is an integer. So even write that one 0. 0 is even a rational number. Write that example even 0. Then the opposite of rational numbers, we call them as irrational numbers. Irrational numbers. You know this prefix IR is used for this opposite of some of the words. Especially when a word starts with R, most of the times the opposite, the prefix is IR. Respective, irrespective. Okay, so that's how you get irrational numbers. So what are irrational numbers? It's the opposite of rational numbers, which means the numbers that cannot be expressed as a ratio of two integers. Numbers that cannot be expressed as a ratio of two integers. Okay, right now before using a black pen, irrational numbers. Irrational numbers. You don't have to just like intentionally give a R pronunciation. Then it sounds like Indian. Irrational numbers. Okay, not in that, it's just irrational numbers. Okay, don't give an intentional irrational numbers. Okay, irrational. So what are irrational numbers? The opposite of rational numbers. Right in this way, numbers that cannot be expressed. Numbers that cannot be expressed. Hey, doi. You can't sleep by writing the note. Huh? Okay. Irrational numbers are numbers that cannot be expressed. Numbers that cannot be expressed as a ratio of two integers. As a ratio of two integers. Numbers that cannot be expressed as a ratio of two integers are irrational numbers. irrational numbers. Okay, so what are the examples? So if you take these root values, root 2, root 3, root 7, these values. So I admit that root 2 can be expressed as root 2 over 1, but root 2 is not an integer. So root 2 is not an integer. So if it is a rational number, we should be able to express it as a ratio of two integers, but root 2 is not an integer. It's not an integer. Okay, then write these examples and show this for 1. Root 2 can be expressed as root 2 over 1, but root 2 is not an integer. Root 2 is not an integer. Okay, the last example that we are going to discuss, number 5, write integers. Number 5, integers. The symbol for integers is a z, but a modified z. The symbol of integers, it's a modified z. Okay, so what are integers? Now look at this. So here, if you consider this rational numbers, so first we have real numbers, and then we have rational numbers. No, no, listen. Focus, look at the board. Sit properly, sit properly. Can't say like in PVR scope, when you go to PVR scope, when you sit, automatically goes in this way. But in COQM, that doesn't happen. No? We haven't given that facility. Okay, so you have to sit properly. Yeah? So here, if you take out these fractions and decimal numbers, and if you only take the whole numbers of these rational numbers, we get the integer number set. So out of these rational numbers, if you take out the fractions and the decimal numbers, the whole numbers are known as integers. What are the integers? -3, -2, -11, these whole numbers, +1, +2, 11, 100, 123, all these whole numbers are known as integers. So now we just we reminded that 0 is even an integer. 0 is even an integer. Okay, and the integers write in this way, whole numbers, WHOLE, all numbers out of rational numbers, whole numbers out of rational numbers are considered as integers, are considered as integers. Okay. So we have positive, look at the board, we have positive integers, which is denoted by this. So positive integers are denoted by Z plus. Plus is for positive. Plus is for positive. So what are the examples we have? Plus, we normally don't write plus 2, 17, 29 in this way. Few. And then negative integers are denoted by Z minus. So if it is a minus, we put the sign, yes, -1, -2, -3, -17. And if I say integers in common, which is denoted by Z, we have the positive integers, negative integers together with 0. -2, -1, we have 0, I'll write 0, 1, 2, 13, 100. So these are integers. So if you include 0 to the positive integer set and the negative integer set, then you have the set of integers clear. So write these three positive integers, negative integers, and integers. So write your examples. Don't just replicate the board. Write the numbers that comes to your mind. So if online students have any doubts, anyways, I'll be talking to the newcomers at the end of the class. For the online students, meanwhile, I'll talk. You can even ask in the chat if there are any problems. And if I ask something from the physical class, whether you understood it, hands up if you have taken the correct answer. I need even you to respond. I need even you to respond. Okay, then write the next main topic. So that is number systems. You have been only like in the syllabus they have given to discuss about number systems, what are numbers, real numbers, the categories of numbers, and then other than these numbers, we have few more numbers, but I'm not going to explain them. We have prime numbers. What are prime numbers? Numbers that you learned even in your primary age. What are prime numbers? Prime, Optimus Prime. What are prime numbers? Numbers that only consist with two factors. Being more specific, one is a factor and the number itself is a factor. So only two numbers, two factors, we say prime numbers. If you have more than two factors, those are composite numbers. Composite. Okay. So you have prime numbers, composite numbers, triangular numbers, square numbers. So we have different odd numbers, even numbers, different numbers. All these numbers comes under real numbers. So that is the main number set. All these categories come under the real number set. Okay. So that is just a brief introduction about numbers. So only what I believe only additional part we have done for A levels is that when you square a real number, you are getting a positive value is the only new part that you have learned today and about imaginary numbers because in O levels you don't have about imaginary numbers. Okay, write the main topic. So this is not under number systems, a new lesson, a new part. Write this recurring decimals. Write this recurring decimals. Recurring decimals. Recurring decimals. Okay. So what are recurring decimals? Now look at these examples that I'm going to write. 1.3333 dot dot dot. 8.272727. 13.729729 Pizza Hut 729. Then we have 7.2626111111. We have this. Yeah, so I have given few examples. Let's go with one more thing. 21.67777. Okay. So what is a similar feature that you can see in all these decimals? In this case, you can see 3 has been repeated. 3 has been repeated without an end, without a termination, without a like any stop in decimal. This has been repeated 3, 3, 3, 3, 3, 3. Here 2, 7 has been repeated 2, 7, 2, 7, 2, 7, 2, 7. To show the continuity, we use this dot, 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 to show that it continues. Here what has been repeated, it's 729, 729. Here what has been repeated, we have 2, 6, but then 1 comes and it gets repeated. Here what is repeated, 7 is repeated. So what are recurring decimals? If a decimal number consists of a repeating part which is repeated continuously, make sure that it should be repeated continuously. These are not recurring numbers. If you have 3, 3, 3, suddenly a 5 comes. Again 3, I mean, just imagine that 5 came. So even though like here, and then again we are having another one, 7. So just even though when you have a recurring part, a repeating part, that doesn't mean these are recurring decimals. To be a recurring decimal, there should be a repeated part in the decimal value. And that repetition or the repeated part should be repeated continuously. It should be repeated continuously. So then you can just denote it using few dots. That is the repetition. So here 729, 729, 729 has been repeated. So these are known as recurring decimals. So what are recurring? So the word recurring means again, 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 and again. No? Recurring. So recurring decimals are decimal numbers which the decimal part of it consists of a repeated part, and that repeated part is a continuous repeated part. Without any termination, it gets repeated again and again. It gets repeated again and again. Clear? So these are recurring decimals, and for O levels, you didn't have recurring decimals. Okay, you didn't have recurring decimals. I know, never mind. Okay, right in this way. Focus, focus. Okay, okay. Can't see any sleepy faces. Okay, I'll give you 1 minute. Drink some water. I can see a few sleepy faces. Drink some water. Everyone who got a bottle, drink some water. Okay, then under recurring decimals, write in this way. Write in this way. Okay, write in this way. A recurring decimal is a decimal a recurring decimal is a decimal in which one digit O, a set of digits, one digit O, a set of digits. Tell me, is repeated or are repeated? One digit O, a set of digits. Is repeated or are repeated? It's is repeated because it's a set of digits. So set means singular. English වගේ ඕනේ කැමති එක කීසුවා ඈම්ලිව තවලන්න. Is repeated infinitely. Is repeated infinitely. So this is how we write infinitely means continuously. Infinite. No, no. Infinitely. Yeah. Is repeated infinitely or continuously. Both are okay. Infinitely, same meaning continuously. Okay, write down these examples. Better if you can write your own examples, then you learn it properly. Better if you can write your own examples, but if you're not sure, you can write my examples. Okay. Okay, so then we use this notation, we use a dot to denote this recurring decimal. So recurring decimal. So this recurring part, sorry, this repeating part is known as the recurring part. The repeating part, the repeating digit or the set of digits is considered as the recurring part of it. So shall we even write it down? So like after these examples, you can just show this, like I have marked the repeated part, show them and then put one arrow, write recurring part. So box the recurring part and then put a red arrow and write recurring part. So that repeating digit or the set of digits is known as the recurring part. The recurring part. Okay. Okay, so this is how we denote this. We use a dot to denote this. A 1.3 dot. So that dot denotes that 3 is the recurring part. So 3 is being repeated. What you know, okay. So 3 is the recurring part. It is what is that? Vasco again. Can't hear the noise again. I heard it twice. Number one, my number one is discipline. I don't know whether it came accidentally, but I can't hear it again. If you have figured out from where did you get the voice, desk එකේ මොන හරි ගත්තද නෑ? රාස්කූරනවා again. Feels like I'm living in Middle East. Okay. So here I can't hear that again. So here this is the repeating part. So we use dots to denote the repeating part. So it's 8 point recurring 27. So how do you pronounce it? Recurring 27. So 27 is repeated. So here, how do we denote it? 729 is repeated. So when it is a set of digits, you put a dot above the first digit and the last digit. We don't put a dot above all three digits. Always above the first digit and the last one. Okay, so then this means that 729 is repeated. How to pronounce it? 13 point recurring 729. Here 7.26 recurring 1. This is 21.6 recurring 7. Okay, then write in this way, write in this way. Recurring decimals can be denoted. Recurring decimals can be denoted using a dot, using a dot, using a dot above the recurring part, above the recurring decimal can be denoted using a dot above the recurring part So we can say in the following manner because you have to write it in the previous one in the above manner. In the above manner. Then you don't have to write it again in front of the same examples. Put equal, equal and write down the notation. So you don't have to write it again. I have given in the above manner. I have made your life easier. Then in the same set of examples, write equals, 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 equals. Okay. So if it is 3 digits that has been repeated, you put a dot above the first digit and the third digit. So it should be the set that is separated. Okay. Okay, then the most interesting part of today's lesson, write the topic, convert in a recurring decimal, convert in a recurring decimal, convert in a recurring decimal into a fraction. Convert in a recurring decimal into a fraction. Okay, okay. Now come to the tute. We have the next topic, recurring decimal. So we have done the basic mathematical concepts. Back we will be coming there. And today, anyone, if you don't have the tute, that is totally okay. That is totally okay. In the group for the online students, I'll ask to share today's lesson, today's tute. Anyone who doesn't have the tute, that is totally okay. I'll just write down the problems on the board. So you can write down the questions and do them when I ask you to do it. So when you do this, when you get registered for our class, you get a silence, silence, silence. I'll talk to the newcomers anyways later, but just mentioning when you register to our class, you get this proper tute, which is named as basic algebra. You get this box file and a syllabus, the English medium syllabus printed as a nice book. I have given it. So when you register, you get it. Okay, for now, I'll put all the questions here. For the online students, even you get the syllabus and the tute, but we won't be sending a box file for the online students. It's not, we can't say not practical, but not possible. Not practical and not possible are two things. No, but you get a normal board file. A nice file. It was nice, no? Last night, everyone got it, no? That silver foil file. Nice, no? Last night? Okay. Never mind. Last night. It's nice. Okay, you get a file, online students. For now, I'll just ask them to upload the tute for today's lesson in the group. Okay. Now everyone, focus, look at the board. Okay, file pen and I know that is nice. Huh? Hey, sit properly. You every time when ones get noted, then throughout the 2 years, if you're going to come, you will get noted. If I see some sleepy faces and if I assume that the class is a bit sleepy, I'll be looking at those sleepy faces. The students who I have noted their sleepy faces. If they are awake, that means the entire class is awake. Okay, so those will be my sleeping meters. I'll be looking at them. If they are awake means the entire class is awake. But if they are sleeping, I need to check whether others are even sleeping. අරගොල්ලෝ හැරිලා නම් පන්තියම හැරිලා. Okay, good. No any sleepy faces. Good. So the most interesting part. So we have to convert 1.3 recurring 3 into a fraction. So this is my task. I need to convert 1 point recurring 3 to a fraction. So this is how we do this. Listen, first learn, then do it. I take this as x. So what is x? 1 point recurring 3, which means 1.333. It goes in this way. Okay, so I'll be telling you, I'll be writing note in this way. In this simplification, in the process of converting a recurring decimal to a fraction, in the process of converting a recurring decimal to a fraction, in that process, there are 2 points that you need to keep in mind. Only 2 points. You need to keep in mind about 2 points. The first point is, you should have this repeating part or the recurring part just after the decimal point. So that is the number 1 point. You need to have the recurring part just after the decimal point. I'll explain when I'm doing this question 8, 9, 10. I'll explain what did I mention. So you need to have the recurring part just after the decimal. So here that is satisfied. After the decimal, the recurring starts. We have 333 after the decimal, the recurring starts. And the other point is you need to have another number. You need to have another number which is having the same recurring part. You need to have another number which is having the same recurring part. In this case, recurring 3333. You need to have another number. Okay, to get that number, what I'm doing here, I'm multiplying this by 10. So when you multiply x by 10, it's 10x. When you multiply this by 10, you get 13.333. So what did I mention? I need to have a recurring part just after the decimal, okay, 0.1 satisfied. I need to have another number which is having the same recurring part. So here is my other number, 13.3333. Okay, then if I take this as 1, this as 2, so my intention or my target is to find x as a fraction. My target is to write x as a fraction. So then I consider 2 minus 1. We have 10x minus x is equal to 13 point recurring 3 minus 1 point recurring 3. So what I have actually written here is 13 point recurring 3 minus 1 point recurring 3. So this is what I have written. So when you subtract this by this, what happens to the recurring part? What happens to the recurring part? It cancels off. No? So when you subtract these two, the no, the one next to you. Yeah, you were just about to sleep. No, good. Now you, not you, the one behind. You. Yeah. You were just about to sleep. No, yes. No, you were zone out. You were going to that zone. Yeah, you were driving your own dream vehicle. But suddenly, then I talked to you. Innovate. You're still on CEO game. Huh? Okay, so here, when you subtract these two, what happens to the recurring part? What happens to the, Solunga, tell me, what happens to the recurring part? It cancel off. So the recurring part cancel off, 10x minus x is 9x. A recurring part cancel off, 13 minus 1 is 12. So x is equal to 12 over 9, which is 4 and 3. So then x is 1 point recurring 3. A 1 point recurring 3 is equal to 4.4 over 3. So now what is my topic? What is the topic that I have given? Convert in a recurring decimal into a fraction. So I say that 1 point recurring 3 is equal to 4 over 3. Now let's check whether this is correct. Now divide 4 over 3. So divide 4 by 3. What do you get here? You have 1. 1 is remaining, you take 0 point. 10 divided by 3 is 3. 9. You can see this continues and you get 1.3333. So what we have done here, this recurring decimal has been converted into fraction 4 over 3. Clear, 4 over 3. Now you tell me, my question is 1.333 recurring 3, is it a rational number or irrational number? 1 point recurring 3, my question is this a rational number or irrational number? Hands up if you are telling it's a rational number. Okay, why is it a rational number? Because it can be written as 4 over 3. This is a ratio between two integers. So it's a rational number. Good. Okay, then let's just write this, write in this way. Converting, converting, converting a ration, a recurring decimal, a recurring decimal, a recurring decimal into a fraction, into a fraction is done in the following manner. Is done in the following manner. Okay, then do the example that I have put on the board. Okay, so near this first and second equations, put a red arrow and red star mark and write in this way. Here. Put a red arrow, red star mark and write in a normal pen. Red arrow, red star mark and write in a normal pen. Write this. In this simplification process, in this simplification process, in this simplification process, we need to consider about 2 points. We need to consider about 2 points. We need to consider about 2 points. Under that, the first point, the recurring part, the recurring part should start right after the decimal point. Right after the decimal point. Right after the decimal point. The next point, we need to have 2 decimal points, decimal numbers. We need to have 2 decimal numbers. We need to have 2 decimal numbers with the same recurring part. 2 decimal numbers with the same recurring part. With the same recurring part. Okay, then do question number 2 alone. It's 7 point recurring 2. Do this alone, same thing, same process, 7 point recurring 2. And you don't have to use X every time. You can use any letter. You can use A, B, M, any letter. To question number 2, 7 point recurring 2. Silence. 7 point recurring 2. So what about the decimals that cannot be turned into fractions? Are they irrational? Yeah. If a decimal cannot be turned into fractions, those are irrational. Okay. 7 point recurring 2. So I'll take it as x. X is equal to 7 point recurring 2. So this is 1. You multiply it by 10 because you know you need 2 decimal numbers with the same recurring part, with the same recurring part. So 2 minus 1, consider the subtraction, you get 10x minus x equals 72.222 minus 7.22 . So like from here onwards, I'm not going to write this. I have written this in this way. So then it is clear. You have a clear idea when it is multiplied, it becomes 72. But if you can just use this notation, this recurring, this dot notation and keep this in this way, then it is more clean and it is clear. So from here onwards, I'll be using this. For this one, I'll just multiply and show. But in here, I'll be only writing this dot 1. Then it is clear this recurring part cancel off here. Recurring 2 and recurring 2, those two cancel off. We have 9x is equal to 72 minus 7 is 65. If you can simplify this, simplify and keep the answer. Simplify means don't convert this to a decimal again, because that is where we started and you need to keep this as a fraction. But if you can see any common factors, you can simplify them. So here there's no any common factors. So 7 point recurring 2 is equal to 65 point over 9. Okay, hands up who got this one. Good. Good. Then do question number 3. There's an additional part you need to think. Anyone who don't have the tune, it's 4 point recurring 37. It's 4 point recurring 37. There is an additional part that you need to think. For the online students, I think they have, yeah, they have uploaded in the group so far. So there's one additional part. Just consider about the 2 points that I have given. You need to have the recurring part starting right after the decimal point, and it should be the same recurring part in both numbers. Then only the recurring part cancel off when you subtract. So you need to have the same recurring part in both numbers. Okay, so here, what is x? X is 4.373737. So now if you multiply this by 10, you get 43.737373. No, so first point is satisfied. You have the recurring part right after the decimal. But I told you, you need to have the same recurring part. So here, if the recurring part is 373737, even in the other number, it should be 373737. So then, if you multiply by 10, you won't get the same recurring part, which means you have to multiply it by 100. No, you have to multiply this by 100. Then only you get 437 point recurring 37. So then only you get 437 recurring 37. So here a 2 minus 1, it's 100x minus x is equal to 437 point recurring 37 minus 4 point recurring 37. So I told you, now it is clear the recurring part. So you need to have the same one. If not, you can't subtract it. And then these two cancel off. You have 99x, which is equal to 433. So x is equal to 433 over 99. Can you see any common parts? No. So then we have 4 point recurring 37 is equal to 433 over 99. 433 over 99. Okay. Hands up who understood this one where I have to multiply by 100. Who understood this? Okay. Then do the next one. Alone question number 4. It is 5 point recurring to 1. Write it. 5 point recurring to 1. 5 point recurring to 1. Okay. Okay. So here now you have the experience. It is 5.212121, which is the recurring part. Then you can't like when you multiply by 10, there's no use because then the recurring term changes. It becomes 121212. So then you need to multiply by 100, which gives you 521.21, 521.2121 in this way. Okay, so here we have this is the first one and this is the second one. So here if you consider 2 minus 1, 100x minus x is equal to 521 point recurring 21 minus 5 point recurring 21. So then you can see the recurring part cancel off. So it's 99x. The recurring 21 cancel off. It's 516. So x is equal to 516 over 99. And here there is a common factor 3. Here there are 33 and here it's 172, no? Yeah, it's 172. So even though you keep it as 516 over 99, that is correct, that is okay, but better to keep it in a simplified way. So then we know 5 point recurring 21 is equal to 172 over 33. 172 over 33. Okay, hands up who got this one. 172 over 33. Everyone got it? No, good. Then do question number 5. Question number 5, 2.123 recurring. 2.1123 or 132? 132 recurring. 2 point recurring 132. Okay, so here we have x. So there are 3 digits in the recurring part. It's 132, 132. It goes in this way. So then, like when you multiply it by 10, now it's not 132 repeated. 100, it's not still 132 repeated. So you have to multiply it by 1000. So when you multiply it by 1000, it's 1000x is equal to 2132.132.132. Okay, so if you want to have the same recurring part, you need to multiply it by 1000. So this is the first one and the second one. So 2 minus 1. If you have the same recurring part, right after the decimal point, you can subtract 1000x minus x is equal to 2132.132 recurrent minus 2.132 recurrent. So then we have 999x. This is where I told about that example previously. So 132 recurring cancel off. We have 2130. So x is equal to 2130 over 999. So here I can see a simplification. It's 710 and 333. But even if you keep in this way, that is okay. So then we get the answer that 2.132 recurring is equal to 710 over 333. Okay, hands up who have kept the answer like from 2130 over 999 or 710 over 333. Any answer is accepted. Hands up who got these two answers again. Okay, now there's an additional part you need to think. Do question number 7. Try to do question number 7. It is, I'll write down the question. 1.2 recurring 6. I'll write down the question here. Question number 7, 1.2 recurring 6. 1.2 recurring 6. Okay, there's an additional thing that you need to consider. Okay, so what we have here is 1.2 recurring 6. Okay, question number 7. We have 1.2 recurring 6. No, no, listen this. Look at this. So here if you write this x, what is x? X is equal to 1.2 recurring 6. So I told you in this simplification or in the process of converting a recurring decimal into a fraction, there are 2 points that you need to consider. So in this case, the number 1 point is even not satisfied. What is the number 1 point? You need to have the recurring part right after this decimal. You need to have the recurring part right after this decimal. So here, right after the decimal, you can't see a recurring part because you have this 2. So even the first point is not satisfied. So then first you need to multiply it by 10. So then you have 12.666. Okay, here this is the first point satisfied, where you have the recurring part right after the decimal point. And the other point is you need to have a similar number. You need to have a number with the same recurring part. You need to have a number with the same recurring part. So if you're going with the same recurring part, you can't simplify these two, because when you simplify these two, this and this one cancel off. That is wrong. So then the other one is you need to have another number with the same recurring part. So I multiply this by 100. So 1000x is equal to 126 point recurring 6. So that is what you do. So when you don't have a recurring part right after the decimal, first you need to make that. First you need to have that. So first focus on having a recurring part right after the decimal. And then get another number of this, and then 2 minus 1 is equal to 10x. 100x minus 10x, which is equal to 126 point recurring 6 minus 12 point recurring 6, which gives you 90x is equal to recurring 6 cancel off 114. So x is equal to 114 over 90. Clear? So you need to first have a recurring part right after the decimal point. You can simplify this by just dividing by 2. So it's 57 and 45. No, you can even divide by 3, no? Which means if you divide this by 3, sorry, 6. If you can divide someone by 2 and 3 both, that means you can divide it by 6, no? So it's 15 here and here it's 19. So then I have 1.2 recurring 6 is equal to 19 over 15. 1.2 recurring 6 is equal to 15 over 19. Okay. Hands up who understood this? Understood this? Okay, who have done this before I did this? Good. Okay, then everyone do question number 8. I need everyone to get the answer here. Everyone do question number 8. It's 23.1 recurring 7. To question number 8, 23.1 recurring 7. So online class students, if you have any doubts regarding this, you can ask in the chat. Okay, so we have 23.1 recurring 7. So if I take it as x, 23.177, this cannot be used because it's not a recurring part right after the decimal. So first I need to have that 10x equals 231.77 this. And when you multiply by 100, it's 2317 point recurring 7. Okay, these two decimals are okay to simplify because they have in the same recurring part, 2 minus 1. We have 100x minus 10x, which is equal to 23.17 recurring 7 plus 231 point recurring 7. So here it's 90x. A recurring 7 cancel off. 7 minus 1 is 6. Here we have 1. So it's 8, 2. So 2026. No? Yeah. So x is equal to 2086 over 90, which means you can divide by simply by 2, 1043, and here it's 45, which means you get 23.1 recurring 7 is equal to 1043 over 45. This is equal to 1043 over 45. Okay, hands up who got the answer, 1043 over 45. Good. Then let's do one more question. Do question number 11. Question number 11, it's 8.3 recurring 7. 8.3 recurring 7. The same story if you take this as x. 8.3 recurring 7, but it cannot be used. So first I need to prepare it such that after the decimal point you have the recurring part, okay? So this is the first one which can be used. We have in the recurring part right after the decimal point, and then it's 100x, which is equal to 837 point recurring 7. 837 point recurring 7. So here it's 2. So 2 minus 1, then we have 100x minus 10x, which is equal to 837 point recurring 7 minus 83 point recurring 7. So 90x is equal to recurring 7 cancel off, and we have 4. Yeah, and here it's 357, no? Yeah, 754. So x is equal to 754 over 90. Is there a simplification? Yes, you can easily divide by 2. No? So this is 377. This is 45. Which means I get 8 0.3 recurring 7 is equal to 377 over 45. Okay. Hands up who got this answer. Everyone 377 over 45. Good. Okay, then take a break and come by 5:45. Okay. Okay, now in the previous example said that we have done, one of the students in the online class has asked a question, silent. Okay, question was, what was the example? Question number 7, silence. So not his, I think her question was, can't we do this in this way to silence, silence, silence. 1.2 recur in 6, and if you take 10x, it is equal to 12.66 in this way. So when we subtract these two, I think when I write this, it will be clear. When you subtract these two, a minus 1.2 recur in 6. So then you can't consider when you subtract this, 666 part goes with cancel off with this. And here it's 6 minus 2. Like when you subtract these two, it goes in this way, and 2, 6, 6, 6. You can't say that this part cancel off and then it is 6 minus 2. That is wrong. You can't do in that way. Because when if you simplify this, like we should be able to clearly say that this recurring part and this recurring part cancel off. We need to be able to say it clearly. So here you can't say, okay, this cancel off, cancel off, cancel off in this way. And then suddenly we have 6 minus 2, which is 4. That is wrong. You can't, like, because these are not finite decimals. So these are not terminating decimals. These are not stopping at a particular point. So it continues. So this is wrong. So the question that she has asked is, can't we take the 9x is equal to then 11.4 and make it over 9 a decimal, which is 114 over 90. So even though I don't think that we get the answer, but even though we get the answer, that is wrong. Like if we get the answer in this way, but this one, like I think this is the answer we got. It's 57 over, yeah, it's 57. No, yeah, this is the answer we get. But doing that in this way is wrong because normally we can't, like what we say is if it is the exact thing, if it is the exact thing that is repeated, we can cancel it off. If not, like we don't write in that way. So even though we get the correct answer, the same answer, when you multiply this by 10, the same answer, don't do in that way. Because normally when you simplify with recurring decimals, you need to have the same recurring part after the decimal point. Okay, you get the correct answer, I admit, but don't do in that way. Okay, then write the subtopic. Write the subtopic. Simplifications related to recurring decimals. Write the subtopic. Simplifications simplifications related to recurring decimals. Simplifications related to recurring decimals. Okay. Okay, now this is what we have to do. Now look at this, look at the board. The easy part. We have this 1 point recur in 3 should be multiplied by 7 point recur in 2. But I mentioned that a recurring decimal is not a finite decimal which has a termination. So here, okay, if it is in this way, let's say you have just 7.2 into 1.3, you can multiply this. So that is possible. Now it is 7 point recur in 2 into 1 point recur in 3. So then you can like don't do any things like new discoveries in mathematics. Recur in 3 into recur in 2 is recur in 6. This is like 21, and don't do in that way. Don't do any new inventions in mathematics while you do like solve problems. If you do such an invention, you can put your own name like Pythagoras theorem. Let's say you are Kasun theorem. Then you can just put it, you can apply the Kasun theorem, you can apply the Sandesh theorem, you can apply Lihini theorem, something like that. Okay, so if you do any new discoveries in mathematics, that is wrong. So what we do when we have to simplify recurring decimals is first thing we convert them into fractions. First thing we convert them into fractions. So now I'm going to convert this into fractions. So now you don't have to do this again because if you look at closely question number 2, every recurring decimal in question number 2 is already in question number 1. So what was the way that I have given the questions? We have converted these into recurring fractions, and now I'm going to use it here. So when you have to simplify these recurring decimals, we write them using factors. So 1 point recurring 3 is 4 over 3. A 7 point recurring 2 is equal to 65 over 9. And then you multiply, you get 260 over 27. So you can keep this as a final answer. You don't have to again divide and keep it as a decimal, because I have mentioned in A levels, fractions are accepted as final answers. In A levels, you don't have to keep a number, an answer in the decimal form. Even you can keep this in a fractional number. It is accepted as a final answer. So bottom line, the summary, when you have to simplify numbers or an expression consists in recurring decimals, what you do? First, you need to convert the recurring decimals into fractions, and then only you simplify using the basic fractional simplifications. Clear? So here, I'll give you the chance. You can directly apply these answers, but let's say you get the simplification in exam paper. What you have to do, first convert this into fraction, get that answer, convert this as a fraction, get the answer, and then only you can apply it. But here I'll give you the chance to use the answers, that use the fractions that we have taken previously, because you don't have to do the same thing twice. No? But always keep in mind, in exam paper, if you are supposed to simplify this, you have to first convert this into fractions, and then you have to simplify. Okay, then write in this way, when we have to simplify recurring decimals, when we have to simplify recurring decimals, first we need to convert them into fractions. We need to convert them into fractions. Into fractions. Okay, then wait, we need to convert them into fractions and then simplify it. Continue the sentence. We need to convert them into fractions and simplify it. And simplify it. Okay, do this one, the first one, and then question number 1, 2, 3, 4. Do all 4. Do the first 4 questions in the tute. For anyone who don't have the tute, the questions 1 point recurring 3 into 4.37, 3.7 point recurring 2 into 5.21, and 2.132 recurring into 7 point recurring 2. So you can use the previous answers. Do the first 4 questions. Good. The online students are asking questions, and if you have any doubt, you can ask. So the previous method that what I explained, you get the correct answer, but don't do that simplification, because there is a high possibility that you can go wrong. So always make clear that you are having the same repeat in part after the right after the fraction. Silence. Right after the fraction, and then you can easily cancel it off. Okay, so it's a simplification. Question number two, 1 point recur in 3, which is 4 over 3, and 4 point recur in 3, 7 is 433 over 99. 433, yeah, which gives you this is 2, 1 is remaining 3, 1 is remaining 1732 over 297. Over 297. Okay, 7 point recurring 2 is 65 over 9. A 5 point recurring 2 1 is equal to 172 over 33. Yeah, yeah. Then what do we have? 65 into. Don't use the calculator because you don't get calculators for the exam. So it's 10, 1 is remaining, 3 is remaining 860, 2, 3, 4 is remaining 1032. Is it 1032? We have 20, yeah. So it's 0, 8, 11, 1, 1. Is it 11,180 over 297? This is what you get. The last one, 2 point recurring, it's 710. No, yeah. 710 over 333 into 7.2 is 65 over 9. So you get the answer. These two I have to multiply again. So it's 27, 2 remaining, 2 remaining. Okay. Over 65 into 71, we have 65, 5, 3 remaining. Is it 46,150? No. Okay. So we get 46,150 over 2,997. Okay. Check the answers. This is 1,732 over 297. 11,180 over 297, 46,150 over 2,997. Okay. Then do question number 5 and then 8. Do question number 5 and then 8. Okay. Question number 5 is 1 point recurring 3 into 8 point recurring 3 7. 8 point recurring 3 7, and question number 8 is a division 1 point recurring 3 over 7 point recurring 2. Use the calculator. It's like you are faking yourself. Just do the simplification, take a rough paper and use a rough paper. Don't use do it in your palm. Very ugly, like marathon deal. Just take a rough paper. You get so many handbills when you come to a class normally. So use them as rough papers. Keep the book and your hand clean. Nah? Okay, so then this is 4 over 3 into 377 over 45, which gives me 8, 2 remaining, 9 again, 2 remaining, 14 over 135. To get this one, 1498. Got it? Hmm. Hands up who got 1498 over 135. Am I wrong? Again, hands up who got this. Yeah, that is what I get. Maybe, is it wrong? 377. 4 into 7 is 28, 8, 2 remaining, 4 into, it's 30. It's wrong. Yeah. Who got this wrong answer? So it's 3 remaining, which is 1000. Okay, hands up, who got 1508 over 135. Okay. So some of the ones who got the previous answer has done the same mistake which I have done. Oh, they have just raised their hands without even looking what is the answer. So it should be 1508 over 135. Okay, so this is a division. It's the same thing, same drill. 4 over 3 over 65 over 9. So after this one, we'll be doing a special part, the special simplification related to fractions. But for now, I'll just do the normal method. You know, when you have to divide by a fraction, you can multiply by its reciprocal. When you have to divide by a fraction, you can multiply by its reciprocal, which gives you the answer. This is 3. It's 12 over 65. 12 over 65. Okay, okay, hands up who got 12 over 65. You got it. Hmm. So I need everyone to get the last. This is the last question that we are doing under this one. Do question number. Yeah, do question number 10. I'll put the question. I need everyone to get the correct answer. Question number 10. It's 5.2 recurring 1 into 1 point recurring 3. 1 point recurring 3 over 7 point recurring 2. 1 point recurring, yeah. 5.21 recurring, 1 point recurring 3. So I'll give time. I need everyone to get the correct answer here. Okay, so 5.2 recurring 1 is 300. It's 172 over 33. This is 4 over 3 silence over 65 over 9. So I'll simplify this in the basic way where I consider the product of the reciprocal when you have to divide by a division. So you can simplify this is 3 and 1, 3 here, it's 11. It's 11. You have, so then multiply this 170, yeah, 172 multiplied by 4, no, it's 8, 8, 2 remaining 688 over 11 into 65 is 65, 65, which is 170. Yeah. Hence I've got 688 over 750. Did I say 170? I have a flash memory. I was telling this as 117. Okay. Never mind. Hands up who got 688 over 750. Okay. So good. So I'll give 1 minute complete the work up to here. So we were working with the simplifications related to recurring decimals. We are working with the simplifications related to recurring decimals. Simplifications related to recurring decimals. Okay. Okay. So before moving on to the next part, I'll just let's mention this because I even mentioned this the same thing in the Sinhala medium class. So when school starts, let's say that you will be getting results in the end of April, and now you don't have to say when the results are coming. It should come someday, when you write exam, like the results are like it should be released. Okay. There's no any exam that you write the exam and the results are not released. So someday it should be released. So whatever the O-level result, let's say you are going to continue maths and then school starts around June, July, probably around July. So when school starts and when you go to school, what happens is like this is a bit like a tragic situation in A level, especially these science streams in government schools. One thing is like the faith towards the yeah, school teachers, the faith in the students' mindset about their school teachers is declining when it comes to the A level section. That is not something good. Even what I advise is if a student asks me, sir, should I go school? My first advice is yes, please go school because this will be the last 2 years that you are going to school. You have been schooling for like 11 years and this will be the last 2 years. So don't stop schooling or like don't go school to just to check whether the school is there. Just attend school properly. And because being honest, there are some good teachers, yeah, in school, some good teachers where they really teach, like they teach really well. But meanwhile, there are some teachers I have noticed, according to what students have like talked with me, because normally like students openly talk with me. Now it is the 2028 class because you don't have anything to talk yet, no. But when you come to the 2027, 26 classes, both in English medium and Sinhala medium, after the class, like in every class, I need to stay for like additional 1 hour to talk with students and to solve their problems. So like I don't know from one end they think that I'm a good listener. So being a listener is good, but sometimes it's annoying because like every time I need to keep listening. And let's say that 10 students are coming to me and they're talking about one problem one by one. Each and every student is complaining, so I'm working really hard, but my marks are not increasing. So if when the 10th student comes, I'm hearing the same story for the 10th time in that given hour. So it's really hard. So it's really hard, but somehow I make sure to give them a proper advice. So from what students have talked with me, sometimes I have noticed that there are some school teachers who are teaching with a personal arrears or the personal arrogant manner towards these tuition sirs. So that happens because students have told me there are some tutors when they enter the class they say, you have learned this in tuition classes, no, then solve this problem and given the problem which is not in the syllabus. So not like anyone in the class won't be able to solve it. So there are, I have been like informed that there are teachers in that way. They come to the class, you have learned this stuff in A-level classes. No, we don't have to teach you because in O-levels, like everyone don't, like everybody, being honest, don't go to classes. No. When I was doing O-levels, I only went for classes for English and Sinhala. English I went because my bunch of friends, school friends went for that class. So I even went. Sinhala I went for the class because Sinhala was there. There was something to learn. Sandhi hema tibbani. We had Sandhi joins. Okay. So because of that, I went to a single class, but I didn't go to math class or science class. But I don't want to ice the cake. But I went to a class. It's not a class. It's one of my friends' mother was teaching us maths because that auntie was a graduate from Moroto University, and then she wanted to teach maths to her own child. But if one of your parents are teachers, you know it's how it is really hard to only learn from your mom or like your mother or father, being the only student in the whole, like in that particular class. It's really hard. So that auntie it was not possible to teach maths for my friend, only my friend. So what did she do? She just collected like few friends of him, like five, six, and then she did a class in Sinhala medium, even though I did O levels in English medium. So that was the only class I went. But when it comes to A levels, like 99% of the students, I can go with a 100%. But our happy cat get 1% is remaining. So I'll just keep that 1%. Not that the remaining germ, but 99% of the students are going for classes, but 1% there might be a very rare possibility where one student is not going for classes. So because of that reason, the A-level teachers at school, some, not everyone, like I had a very good combined maths teacher where I have learned about 40% of the syllabus I learned at school, not from classes. A really good, like even still I call sir who get some advice related to teaching and this all, I still have contacts with him. So there are some teachers who take this for granted. They know that every student here is going for a class, so they will get the syllabus covered. So they just come and get cover these all these personal areas and given, okay, you have done this at school, no, at tuition classes. No, then solve this problem. මර කියන්නේ එමය. A class වල ඔක් කරලා තියෙනවා මේක හදන්නකෝ බලන්න කියලා, and they are given a problem which is not in the syllabus. So when we cover the syllabus, when we cover the lesson, when we do all the past paper questions, if the question is not in the syllabus, how in which world, how can that student will be able to solve that problem? Unless the student is having a high IQ, this Olympiad type person can't do. And then when the students can't do that, he's just mocking බෑනේ කරන්න බෑනේ. කියලා that ඕක තමයි වෙන්නේ classes පැත්තේ ගියාම. You might hear similar stories. But meanwhile, I need to appreciate there are some teachers who are using this tuition factor or tuition these they are taking this for granted that the students are taking like covering the syllabus, getting the syllabus covered somehow, but they're using in a good way. I know there are some teachers who are coming, let's say, and they're asking the students, you all have done the theories of this lesson. I know that you have done the theories of this lesson in a class. So then I won't be explaining the theories from the beginning. So let's do some good problems in this lesson. So that is something really good. No? Let's say you learn the fundamentals of a lesson in a tuition class. And then your class teacher says, okay, then you don't have to again learn the fundamentals or the theories. Let's do some good questions in this lesson. So that is how a school teacher should be. So once, like when we did this recurring decimal part, conversion of the recurring decimal, sit properly. The conversion of the recurring decimals into fractions, and then one of the school teachers, sir, has like he has explained that in another method. So there is another method you can do that. That is completely okay. So one of my students who were in the class, the school class, he has approached the sir, the teacher, and asked, sir, අපේ ස්කූලේ මට class එකේ sir මෙහෙම කියලා දුන්නේ. My tutor like explain this in this method, and then he has done this method, this one, the way that we were just doing. And then sir suddenly he has like blasted, ඕක වැරදි, ඔහොම හදන්න බෑ, this is wrong, the method is wrong. අවගොල්ලන්ගේ සර්ට කියනවා, he was like challenging me, not directly through the student. So student is like the messenger. He brings the messages to me. අවගොල්ලන්ගේ සර්ට එහෙනම් කියන්නකෝ ඕකෙන් මේක හදන්න. Tell your tutor to solve this, convert this into a decimal, convert this into a fraction using his method. This is not my method. This is not Mandapa theorem or something. When you search in Google Mandapa theorem, such a theorem do not exist. Okay, does not exist. So this is a general theorem that this is something that we use in maths. So then he has sent me to solve this 0 point recurring 9 using this method, which he called my method, not my method. Convert this into fraction. So he has sent that. So when we do this, x is equal to k, 0 point recurring 9, you multiply this by 10x, 9.999, and when you subtract, 10x minus x is equal to 9 point recurring 9 minus 0 point recurring 9. The recurring part cancel off. You get 9x equals 9 and x is equal to 1. So you get 1 when you do this in this method, which means apparently 0 point recurring 9 is equal to 1. So when we do this in this method, you get this answer. I know that like, this doesn't sound correct. No, 0.9999 is close to 1, but that is not equal to 1. So when you do this even, 1 point recurring 9, you get this is equal to 2. In the same method, you get this is equal to 2. 2 point recurring 9 is equal to 3. So when you follow this method, you get this answer. Okay, then I said, okay, we get 1. When I asked 2 questions, again, the student is the messenger. Student is the messenger. If this method is wrong, explain or teach the student a method where you can convert 0 point recurring 9 into a fraction. So that was my first question. Is this method is wrong? Okay, if this is wrong, send me a method where you can convert 0 point recurring 9 into a fraction. His answer was no, there's no such method. No such method. My second one, okay, if this is wrong, tell me a fraction that gives us 0.999 recurring 9. There is no any fraction that gives you 0.9999. My second question, no, there's no any fraction that gives you, like, what gives you 0.3333? 0 point recurring 3, which fraction gives you that? 1 over 3. 1 over 3, when you divide 1 by 3, you get 0.333. So I was asking, okay, give me a fraction which gives you 0.999. So there's no any fraction like that. So then what can we do? And then after he gave me the answers, okay, so this is wrong because like I don't have any, like I respect my school teachers and I even told you my personal advice to everyone here, go to school because this will be the last 2 school like years that you're schooling. And if you can get something from the teachers who are teaching in your 11th section, at least if there's 1% of thing that you can get from them or learn from them, learn that. Because I told you I covered like 30 to 40% of my combined math syllabus because I missed so many classes because I did few extracurricular activities, not few extracurricular activities. So I missed classes. My combined math class was on a Friday. So like there were Fridays, like every Friday, like week after week, I'm missing the class. So I went early morning to the school and I asked my class teacher before I asked him, sir, can you like he's anyways coming around 6:30. So I was asking him, sir, can you explain me this lesson, this lesson, this lesson? So in that way, I have done around 30 to 40% of the syllabus got covered from him. So I have a huge, immense respect to school teachers. But the tone that some of the teachers are bringing these questions are wrong. He could have he could have mentioned that politely, like in this method, there is a error, like just you can discuss with your tutor, check how to take 0.999. So there's a polite way, without telling this is wrong. How can you tell, okay, ask your tutor to do 0.999. So like he couldn't answer my 2 questions. And then I just wrote this and sent this. So tell me whether this is wrong. What? 1.1 over 3 is equal to 0.3333. Do you admit this? Do you admit this? Yes or no? Yes or no? Yes. And now I'll multiply both sides by 3. I multiply both sides by 3. 3 cancel off. 1 is equal to 0.9999. So this is what you get. Even if you ask ChatGPT to convert 0 point recurring 9, you can just check it now even. Okay, not now, after the class. Ask ChatGPT to convert 0 point recurring 9 to a fraction. You will be getting this exact thing. You'll be getting this exact. If you have a problem, say 1 is not a fraction, 1 is equal to 1 over 1. Okay, but you'll be getting this exact thing. Okay, so that's why I just make mention this, because in case when your school teacher do this lesson like at the class, and if he brings something like this personally, like when he just openly say this, you don't have to just go and like ask for the war. How can you say okay, so this is in this way, so this is how you can do this in this way. You don't have to do in that way. Behave properly. But if he like approaches personally, and then you can just go ahead with these explanations. Okay. And now don't do this when your sir doing this method, like sir explain this method what we did. Now don't go and tell him, sir, this is wrong. Convert 0 point recurring 9. It's wrong. You don't get the answer. Don't do that. Okay, so there's a small error here, but that is even accepted in maths. Okay. Okay. Then so we are done with recurring decimals. So let's do the last part of basic maths concepts, but you can write in the same one, no? Same page. You don't have to go back to the basic mathematical concepts. Now don't think about it like hands up who understood this. Ille? Good. Okay. Okay. Write the topic simplifications related to. No, wait. Write the topic fractional simplifications. Silence. Any questions in the online class? Ask the topic fractional simplifications. Any questions? No. Okay, fractional simplifications. Okay, so here I'll be explaining how to easily simplify fractions under three main types. Okay, under three main types. The first type is, you can write in this way, write in this exact way, type 1, type 1. Using a black pen, write that, and then using a blue pen, write A over B divided by C format. Type 1, A over B divided by C format. Okay, what is this format? Fraction in the numerator. So we have a fraction itself, and even inside that fraction, inside the numerator, we have a fraction. Fraction in the numerator. Fraction in the numerator. So what is this format? Fraction in the numerator. Fraction in the numerator. Okay. So now this is what happens here. So if you go with the basic simplification, if you go ahead with the basic simplification, when you have to divide by someone, you multiply by its reciprocal. You multiply by its reciprocal, which is 1 over C. And then you get the answer A over BC. So there's a reason why I'm asking you to do these simplifications. I'll tell you in a while. So now look at this, what happens here. When we have a fraction in the numerator, you don't have to write this separately as a reciprocal. What you can easily do is this denominator B comes down. That's all. So when you have this, you don't have to even show this in terms of a reciprocal. This denominator straight away comes down. So how we can use this as example? Example, if you have A over 2B is divided by 4C. So A over 2B is divided by 4C. You don't have to write this as a reciprocal. Straight away, bring this down. That's all. I'll tell you the reason. Straight away, bring this down. So then you have A over 2B into 4C, which gives you A over 8BC. A over 8BC. I'll take another example. So this is the first example, and this is the another one. Let's say you have this m squared plus n. This is divided by 2 over k. So how we can simplify this? First, simplify the numerator. So when you simplify the numerator, take 2 as a common denominator. M squared plus 2n are divided by k. So what we learned now, when you have a fraction in the numerator, this fraction directly comes down. That's all. This directly comes down, which gives you the answer. This is equal to m squared plus 2n over 2k. This is equal to m squared plus 2n over 2k. So what can you do is when you have a fraction inside the numerator, the denominator directly comes down. Okay. Hands up if this one is clear. Okay, first write this down, then I'll explain you why am I expecting these type of simplifications. I'll tell you the reason. Okay, so first this is the format. Write this down. So this is what you get. You don't have to square this or box it. No, not needed. Just write it. Learn what happens here. The denominator straight away comes down. I told you I'll be explaining fractional simplifications or simplifications of fractions using three formats or three types. Do the two examples. We first just write this one, the main one. So what happens? The denominator comes directly down to the denominator. Do these two examples, and then in the previous page under basic mathematical concepts, question number 10. Do the first question. So basic mathematical concepts. Question number 10. Do the first question. A over 2 plus 3 divided by a plus 1. I want you to simplify this. It's a minus 3, no? A minus 3. Page 4, question number 10 under basic mathematical concepts. I have write down the question, so anyone can take it down. Okay, so what happens here? You take 2 as the common. First simplify the numerator. Okay, a plus 6 over 2 divided by a minus 3. And then 2 comes down directly, which gives you a plus 6 over 2 times a minus 3. A plus 6 over 2 times. So 2 comes here, it's 2a minus 3. So if you just write the denominator as 2a minus 6, that is okay, but not needed. That's what I just want you to understood, that 2 directly comes down. Okay, hands up who understood this one, this part. Okay, now the reason why am I expecting or teaching these kind of simplification is this. When we move on in combined maths, we will be working with fractions which consist with large terms. We are not going to simplify them. Make a simplification. I don't have to explain this method. But imagine you are going to simplify a fraction which is in this way, huge terms, like which consist around 3, 4 terms inside one bracket. And in this case, if you spend an additional step to write the reciprocal, it takes time. So here, if you're going to take an additional step to write the reciprocal, so that takes more time. Aparade. So you can easily do this. What happens when you know the denominator here directly comes down. Okay, so I'm just preparing you not for these, not for these. Don't think in A levels you get these. This you can just simplify, I admit. But when we are moving on with lessons like relative velocity, equilibrium, there are final answers, even final answers, which consist of around more than 14 terms. Okay, final answers, like you might see final answers which consist around with up 7, and like you have 7 in the numerator, 7 in the denominator, and like 14 terms. That happens. That happens. So then you need to get prepared by doing small things, and then you have these big fractions, you can apply the same thing. Okay. Okay, so the first format is, or the type is, when we have a fraction in the numerator. Fraction in the numerator. The second one, type 2, right, in the same way, type 2, it's this format. We have A over B over, sorry, we have A over B over C, which means we have a fraction in the denominator. We have a fraction in the denominator. Fraction in the denominator. Fraction in the denominator. Okay, so what happens here? Now look at this. If you simplify this in the normal method, we know when we have a division by a fraction, you have a division by fraction, what do you normally do? Divide in by a fraction, how do you solve it? Tell me, how do you solve it? When you have to divide by a fraction, what you do? Yeah, no, properly. Multiply by its reciprocal. Okay, you multiply by its reciprocal. So here, you multiply this by your reciprocal, C over B, which means you are getting AC over B. Look at this. So what is the final result or the final shape that we have got? What is the final result? So here, when you have this A over B over C, this denominator C directly comes up. So look at this example. Here in this example, the denominator went down. The denominator came down. Here what happens? The denominator goes up. So you can directly use that. When you can see in this way, the denominator goes up. Example, we have 2a over m plus 1 over n. How can you directly write the answer? What happens? Tell me. Who goes where? කවුද කොහෙද යන්නේ? n goes up. සිංහලෙන් නම් n උඩට යනවා. Okay, n goes up. And then we have, you can directly write the answer one step, 2an over m plus 1. 2an over m plus 1. Clear? Okay, so this is, then write this and get this answer, this example. And I'll put another example so you can do it alone. So there's another example for you. do this example. So the new students who have joined online, like after the class, don't leave. I'll just speak to you all, like including the physical class students for like 5 minutes. So don't leave after the class. The new students in the physical class, anyways, I'll ask you to stay, and even online class, don't leave the meeting, not the meeting, the class. Okay, this example. So what happens here? First, simplify the denominator. For that one, you need to take 6 as the common denominator. So then this is 3m squared minus 2n. 3m squared minus 2n. So then 6 goes up. So it should be 6 into this one. So 6 goes up. You get the answer is 6 times k plus 2 over 3m squared minus 2n. So when this 6 goes up, this numerator should be multiplied by 6. When 6 goes up, the numerator should be multiplied by 6. Okay, 6 times k plus 2 over this. Okay, so in type 1, we had a fraction in the numerator. In type 2, we had a fraction in the denominator. Then what should be the type 3? No fraction. What should be type 3? Fraction in both the numerator and the denominator. Okay. Then type 3. So when you know these three simplifications, you can do any fractional simplification. So we have A over B divided by C over D. Format. Silence, silence. Fractions in both the numerator and denominator. Fractions in both the numerator and denominator. Fractions in both the numerator and silence, silence, denominator. Fractions in both the numerator and the denominator. Okay, so here this one is a combination of type 1 and type 2. Okay, now look at this. In type 1, we had a listen. Last part. In type 1, we had a fraction in the numerator. So I told you when you have fraction in the numerator, what happens? That denominator in the numerator comes down. No? The denominator in the here, look this one. The denominator B in the numerator comes down. So that is what happened in type 1. In this case, when we have a fraction in the denominator, this denominator goes up. This denominator goes up. Now here, it's a combination of the first and second type. No? So here it's a combination. So if you write down the normal simplification, A over B over C over D is equal to A over B multiplied by the reciprocal D over C. So you multiply by the reciprocal, which means you get AD over BC. So here, look what happens here. It's a combination of the two types that we have discussed. The denominator in the numerator comes down. The denominator in the numerator comes down. The denominator in the denominator goes up. Same thing. This comes down. This goes up. You get AD over BC. Example, look at this. Example. We have silence. Look at this. Let's say we have A squared over 2B divided by A over KC. Okay, so what is my simplification? We know this denominator goes down, this denominator goes up, this denominator goes up. So then it is equal to a squared into kc, this is equal to a squared goes up, a squared into kc over, when this comes down, 2a into 2b. So you can see there's another simplification which can be even done initial. I'll explain that. A and a cancel off, which gives you akc over 2b. Clear. So what happens here? This goes up, this comes down. So you have this, and then a get simplified, akc over 2b. Okay, write this down and the example. Then I'll give another example. I'll give another example. We have so like if you find this, like if you think this is a bit confusing, okay, just go with the normal method. With time, slowly, let's practice this. But now, in like at this stage, if you find this a bit confusing, totally okay. Just write the reciprocal and do the normal simplification. I'm just doing a small help for your simplification. But if you find it confusing, because I need the final correct answer, it's okay that you have considered any method. I just want the final answer, the correct answer. Okay. So here, how can you simplify this? Look at this. First, simplify the numerator. Take 6 as the common denominator. So it's 3m squared plus 2n, okay, over k plus 1 over p. So what did I mention? What happens here? This denominator goes up. This denominator goes up and this comes down. This comes down. So now we can write the final answer. So when this goes up, it is 3m squared plus 2n times p over, when this comes down, 6 times k plus 1. So what happens? This p goes up. So this factor, this 3m squared plus 2n should be multiplied by p. And then this 6 goes down. You have 6 times k plus 1. Okay, then do question number 4 in the same set of questions. I'll write down the question. I'll write it here. 2a over b cube. Question number 4 in the same set of questions. Over a squared over d. Over a squared over d. Okay, okay, then what happens here? D goes up. Silence, silence, silence. In 2028 classes, I don't have to mention the word silence. Once you hear my voice from the speakers, you need to be silent. So 2a d comes up. This goes down. We have a square b cube. So then the final answer is 2b over 2b over ab cube. So this is how we can do this. So still, if we want to multiply by the reciprocal and get the answer, that's okay. You'll be getting the same answer. Okay, hands up who got this format 2b over, it's d b velani. Just like in the Tare Samipar. Have you watched that film? No, Tare Samipar, where Amir Khan is the main character in that film. The child is having a disease called dyslexia. Dyslexia is where the letters that you always mix up this D and B. I don't have dyslexia. I just know that it. So that is yeah, that is what happened. You cannot dyslexia. Hands up who got the answer 2D over ABQ. Okay, good. Okay, now from what we have learned, try to do question number two. I'll teach another simplification. Do question number two in the tute. I'll write the question. Silence, silence, silence. 2 over A plus, wait, no, it's 1 over A, no? Yeah, it's 1 over, I'll write it, wait, 1 over A, 2 over A plus B, silence, silence. So A plus 1 over B over A plus 1. So any questions, the online students, you can ask now. Okay, no any questions yet. Okay, then so first simplify the numerator. A times A plus 1 over, now A plus 1 goes here, plus A goes here. So it's a normal simplification when you take this common denominator that I don't have to explain. Okay, over 3 over A plus 1. Okay. So now what we learned is there's another simplification. I'll explain it here. So that's why I wanted you to do this question. So this comes down. This comes down and hey, my friend. Okay, so this goes up. Hmm. So here, what do we get when you simplify this? It's A plus 2A is 3A plus 1. When this goes up, it's A plus 1. So this entire factor goes up. And this comes down, we are having a 3. And this comes down, A times A plus 1. But you can clearly see a simplification, A plus 1 and A plus 1 cancel off, which gives you 3A plus 1 over 3A. Okay. So let me explain you a easier simplification here. Now look at this. At this stage, when you have this one, okay, so you simplify this. No. So I'll give this as a note, 1 over 1 plus 2 over this over 3 over a plus 1. So first simplification is a normal one. You take this as a common denominator, which gives you a plus 1 plus 2a. Okay, now look at this carefully. Okay, look at the board. Okay. And again, I'm repeating that I don't expect you to like be perfect in these simplifications right after now. Memang karapu gaman, you don't have to be perfect. But it's better, like there are so many questions in the tute, remaining 12 questions, and then you have weekly questions. Okay, and then what you can do is you can practice them and then have the practice. But still, if you're telling me, sir, I find this a bit confusing, I prefer to write it as a reciprocal and multiply, you can go ahead with that method. That is okay. But somehow during this journey, you need to practice this one. If not, you will be finding hard or you'll be taking more time to simplify these big fractions. Okay. So here, what you can do when we have fractions inside fractions, when we have fractions inside fractions, the two numerators can be simplified. Simplified means common terms can be taken out. The two numerators can be simplified and the two denominators can be simplified. So here you can see clearly a plus 1 here and a plus 1. So you can once at one step, you can cancel off it. When we have fractions inside fractions, like double-decker buses inside double-deckers, okay, what you can do is the two denominators simplify and the two numerators simplify. Okay, now look at this, how easy this is. You can see this a plus 1 cancel off. Only a is remaining, it comes down. Only a is remaining, it comes down. We have 3a plus 1 over when a comes down, it's 3a. So you can easily do the simplification in this way. When you have fractions inside fractions, mark my word, the two denominators can be simplified. Simplified means common terms can be cancelled off. The two numerators can be simplified. Clear? The two numerators can be simplified. Okay, hands up. Who understood this one? Understood this? Okay, then write in this way, put a red star mark and write in a normal pen. Last one. Red star mark and write in a normal pen. Right, this when we have fractions in fractions, when we have fractions in fractions, when we have fractions in fractions, the two denominators, the two denominators and the two numerators, the two denominators and the two numerators can be simplified. The two denominators and the two numerators can be simplified separately. The two numerators and the two denominators can be simplified separately. Okay, then do this example. Same example in this way. Same example in this way. And as the last question, I need you to do question number 5. Last question. I need you to do question number 5. 2 over x plus y minus 1 over x over 3 over x plus y over x plus y. Okay, so use this simplification. When you can see common terms in the denominator itself can be simplified, in the numerator still can be simplified. I want you to do this in 1 to 2 steps. I want you to do this in 2 steps. Okay. So first one, you need to separately simplify this x plus y. So this goes here 2x minus put like a step backward. Okay, so then this is x times x plus y. Silence, silence, silence. This is multiplied by 3. This is multiplied by xy. So what did I mention? When you have fractions inside fractions, the denominator can be simplified itself. No? So what happens? X plus y to x plus y cancel off. X to x cancel off. Clear? So you can simplify both the denominators. So here in the numerator, it's 2x minus x minus y. I'm again telling that if you didn't get the answer, that is okay. Yeah? That is okay. But try to practice the remaining questions and the week 2 questions so then you can do this perfectly. You get x minus y over 3x plus 3y plus xy. 3x plus 3y plus xy. Okay, hands up. Who got this, sons? Madi, Madi. There are half of the class haven't done it. Do question number. Yeah, do question number 8. Do question number 8. I'll put the question. I need the entire class to get the answers. If not, we can't finish the class. Question number 8, I'll write down the question. It's my bad that I can give at least one page of the tute. Okay. 8 is equal to 1 over A. I need everyone to get the answer. If not, I'm doing another question. Now, 1 over A minus 1 over A plus B. 2 over A minus A over A plus B. Several like make sure like in the last question of the class you have to somehow do it because then you are leaving the class with that mindset. Even though you do all the questions throughout the class and you don't do you won't be able to do the last question, then you are having a negative mindset. I couldn't do this question. But the opposite is better. Even though you don't do any question during the class and you get the answer for the last question, then you are leaving the class with a positive one. Antima gane hadunane. That is what matters. How you finish it, not how you start it, how you finish it. Okay, so first simplify the numerator and the denominator. You get a times a plus b. Okay, so a plus b goes here. This goes here minus a. And again, same thing, a into a plus b. It's 2 times a plus b. A plus b. And here it's minus a squared. So now it's clear that you're having the same denominator a times a plus b. So it cancel off. Here, what happens? A minus a cancel off. So then you get the only term remaining in the numerator is b because all these have cancelled off. You get, yeah, you can write the final answer, no? Because this one gets simplified. You have b here, b over 2a plus 2b minus a squared. You get b over 2a plus 2b minus a squared. Okay, hands up who got this final answer. Okay, if you are done, you can get ready to go. Okay. Okay, silence. 1 minute, 1 minute. Okay, silence. Okay. Okay, so then today we started the syllabus. Silence. We started the syllabus. We did PO maths and we started the commencement of the syllabus with numbers, and then we did this recurring decimal. So next week is the 13th, which is the got into Sinhala New Year, that is all New Year. So it is a New Year vacation week for every institute. So next week we won't be having classes. It's a holiday. And then again, we will be meeting on the 20th of April and we are starting another new lesson. Inequalities, it's in the same tute. Okay, same tute. And April 20 and 27th, we will be doing inequalities. And then it's April 20, 34th. No, 34th means 4th of May. We'll be having the first term test, main paper one, where the top 10 students will be awarded by medals. And like it's a proper exam, like based on what we have done for the first 2 months. Okay, so we will be starting inequalities. Bring the tute and new students, even though you haven't got the tute by then, I'll separately print the inequalities part like A3 paper and give it to you when you come on the 20th. So that is the main thing. So I need the students because I only spoke in the very first day, and for the students who joined the class during the second, third, fourth weeks, I didn't spoke to them separately. So I need the students who have joined the class. Like if you know about the class, if you know the Telegram group, if you know about me means my you know about me means my teaching. And if you are in the Telegram group, then that is okay. All the other newcomers, especially the students who came today, just remain after the class. I'll talk to them separately for maximum of 5 minutes. And online students, don't leave the meeting after this one. Just remain for 5 minutes. I'll tell you how the class happens. Okay. Okay. So we are done for today. You can go home safe. I'm not going to eat you all. Yeah, I don't have to use the mic, but I'm using the mic. It's not me as well. The online students like thinking like I use that. What is the prime time you have to pay before 7:20? No, is it already past 7? You need to like. Is it okay if you pay by 7:25? No, not haram. No. All good. Okay. Okay, so I'll just use the mic because for the only because of the online students. So first thing is I hope that today, even though you are newcomers, since we started a new lesson, recurring decimals and these numbers and this one, I hope that like you understood today's part. So I'll just briefly say that what we have done so far for the first 4 weeks, I talked about this bridge where I was connecting O-level maths and A-level maths, and we did it under 4 days, basic mathematical concepts. Okay. And I even know that, and I don't want any student, like when they come in the very first day, I don't want even to ask them to watch the recordings of the previous 4 weeks, because I know you won't do that. Okay. Because you are just new to A levels. If I ask a 2026 student when he or she misses the class, if I say watch the recording and come next week, probably she will do that. She or he will do that. The reason is because they know how you need to do these A levels. So when I asked a 2028 student where A levels is not very, it's like 2 years more. And if I expect you to watch all the 4 recordings, even though we are having the Urdu vacation, and come on the 20th, that won't happen, and you don't have to watch it. But I want you to do one thing, because when you're doing A level maths, I need you to be crystal clear about your future and your path. So the only thing that we will be uploading, even for the online students, we will be uploading all the 4 recordings we have already uploaded in YouTube, but I'll ask them to upload them to the group. So you can watch them freely. Even though the online students who have joined the class, they have done a payment to join in March, the recordings for the first month, I'll be giving them free. So I want you to watch the day one and the first 2.5 hours of day one. Because in the very first day of the class, I have comprehensively discussed or explained about what are the parts of maths. Every part, not only engineering, not only IT, not only AI, data science. I have explained about how can you do architecture, how can you do fashion designing, how can you do this, how can you go in the commerce stream, the management, how to become a lawyer, even after doing maths, and then all the engineering avenues, like probably you know about software, electronics, civil, mechanical, but I think you don't have even heard about chemical engineering, biomedical engineering. So I have spoke about every avenue, like not every avenue, 95% of the careers that you can follow when you do A level maths. So why do I want you to watch that? Then you have a clear, crystal clear understanding about your future. Then you want end up A levels. Then after doing A levels, you get to know, when I do maths, I can't be this particular person. But you have a clear idea. And I have spoke about the subject combinations, whether doing ICT, what to do, like should I do ICT, should I do chemistry, or any other subject combinations. I have talked about them also. I don't recommend to do ICT, I don't recommend to do chemistry. That is your decision. But I have spoken that first 2.5 hours based on your combination, what are the faculties that you are eligible to get into and what are the faculties you are not eligible to get into. Okay. So luckily you came in the very first day, because even like if a student comes on in the first 2 3 months, that happens, students come as newcomers. So even you come on the, like a newcomer come on the 20th, he or she will be able to understand it, because we are starting a new lesson. And I hope by now you have found proper classes for other two subjects. And if there's anyone here who just started classes, my advice is even the best one, go to another class, and then you can compare and select the class. Even I say that is open for maths. I want to ask you, okay, you came to this class, you came to the best combined maths class in the island. No, I won't say in that way. You have the freedom to go any other class, and then you can compare and you can teach. But I'll assure you one thing, that I'm doing the English medium class 100% in English, because I just don't just pop out the words in English, or I just don't give the tut in English. I teach in English because I'm confident about my English ability, English fluency, so I can teach in English. So like that is something special in our class, because I know in some of the classes, even in Ukegoda, even though they market as English medium classes, the tunes are in English, the topics, terms, notes are given in English, but they explain in Sinhala. For some students, that might work. If you are thinking in Sinhala, that might work. Sinhalin hitanawa nan eka hari. But I do this English medium class, 100% English, because I'm doing a separate Sinhala medium class, which is 100% Sinhala. Here, like when I crack a joke, when I give an example, I might very rarely use this Sinhala words, තේරුණාද කියලා අහන්න. And even I might ask that in Tamil, වලංකින්ච, something like that, තේරුණාද. If not, like all the explanations will be done in English. Hope that is okay with you. Okay, because you are the English medium class, no? So that is okay with you. And if you want anything to know from me, from my end, even online students, you can send me a message if you want any details. And normally in online class, and the other thing, another facility in our class, we are live streaming this class. So let's say any student won't be able to join a particular physical class. You are not well today, so you won't be able to join the physical class. What you can do, you can join the online class. Okay. So first thing, get added to our Telegram channel. So if you like, you can search in Telegram 2028 Combined Maths EM. Okay. and my name is Mandava Panditike, then a channel will come and get added to that channel. If you can't find the channel in like Telegram, it's a public one, send a message to this number and ask for the link of the Telegram channel. So when you go to the channel, just read the messages that we have posted before. Then you will have an idea about our class. Every first week we will be uploading for the online students. We will be uploading the first week because even in a physical class, the first week is free. That doesn't mean when you come in the second week and you don't pay, you can't come in. Nothing like that. But normally, like first week, we don't even check for that. From second week onwards, only we are checking. So we'll be posting the YouTube link, and all the online classes are YouTube classes to the group in the very first week, but then after you have to join from the website. Okay, so here, even if you won't be able to join for a physical class because you're not in Colombo, not well, you can join the online class. And even if you won't be able to join the online class, you can watch the recording. The recording will be uploaded to the site soon after the class. You can watch the recording and cover the work and come next week. So you don't have to think about these weekly question thing, but if you read the messages in the Telegram channel, you will find that I won't be checking the weekly questions homework of the newcomers, but on 20th, I'll be again mentioning about the weekly questions. So then you have to do that. Weekly questions is like a small thing. Today we did recurring decimals and fractional simplifications. No? So in 2 days in the week, Monday, including today, Monday and Wednesday, we will be uploading a set of homework to the Telegram group that you need to do them alone at home. So week after, when we do inequalities, based on what you have done at the class, like in the class on that particular day, you will be getting homework posted in 2 days, Monday and Wednesday. So you have to cover them, and the marking scheme will be uploaded. You have to then check them, and then I'll be doing random checks to see whether you have done them. But for you all, I won't be checking it on the 20th. But when you're moving forward with the class, better to do them because that gives you good practice. If not, you close the book today, you go home, you bring it back, you open it. And even if something that you have kept like an incomplete problem, it will remain in the same way. Okay. තේරුණාද කිව්ව එක? පොත මෙතනින් වහනවා, ගෙදර යනවා, ඇතුළට දානවා, ගානක් බාගෙට ලියලා තියෙන්නේ. ආයේ පොත අරන් ඇවිල්ලා පොත දි කරනවා, ගාන බාගෙට හදලා තියෙන්නේ. So that is what happens at the initial stages of your A level. So to stop that, to prevent that, is what I have done is we are doing these weekly questions. Okay. Okay. So if you have anything furthermore to get clarified, you can talk to me after the class. Okay. You can go home.